Hi, welcome to another lesson with Dr. Hill. Today what we're doing is we're going to be talking about the reactions of alkenes. Now alkenes have a double bond in them. They're unsaturated hydrocarbons. They're unsaturated because it means we can add more atoms to the molecule, and if we're going to add more atoms to the molecule, we call this reaction an addition reaction. Couldn't be simpler. Addition reactions. So let's take, for example, this fella here. We've got this hydrocarbon, this alkene. It's got 1, 2, 3, 4 carbons. That makes it butene. The double bond is on the second carbon, makes it but2ene. All right, and as you can see, I can break one of these bonds off, and I'll still have my carbons attached. Right now, you might think, well, there's only one bond left sticking out, but you have to think about breaking this bond as in leaving one bond on each carbon. Right, so it's like that. Not like that, like that. Okay, so what we have is we have now 2 free bonds. All right, and if we can get a substance to react with this that will easily give us valence 1 structures to put on here, particularly valence 1 atoms, we can do reactions relatively easily. So we can do a reaction relatively easy with hydrogen gas, which if I break this bond, I will have 2 valence 1 atoms. I can also do this with the various halogens, and I can break that. And in fact, the halogens we're going to talk about, and I'll show you, I'll link you to a video on that, because this is a test to test whether you've got saturated or unsaturated hydrocarbons. You use bromine, which is a brown solution. If you drop it in here, it binds. So let's just do that reaction. I've got my, remember, this is double bonded. And then in the reaction, I break the bonds. Okay, so I break that bond, and I break the bonds on the bromine. Now, when bromine becomes attached to the alkene, it then becomes an alkane with bromine side chains. These bromine substituent chains here, and that will now become it's butane, and it's going to be 2,3-dibromobutane. Okay, but the important thing is that this substance is colorless, right? Colorless, whereas bromine itself, when it's still in its ordinary state as Br2, remember, diatomic molecule, is brown in solution. So if I add this to this, yeah, and get a reaction, and it reacts itself at room temperature very easily, the alkene breaks open, grabs the bromine, and the solution becomes colorless straight away, pretty much. I'll link you to that reaction. So bromination, or using bromine water, a solution of bromine, is a good way to test the difference between an alkane and an alkene. If you want to test for an unsaturated hydrocarbon, use bromine water. If the bromine water goes clear, then you've got an alkene. All right, so let's get moving on looking at these reactions. The other reaction that you can do, of course, is you can take water, because water will break down to a valency 1 hydrogen atom plus a valency 1 hydroxide ion, which can join on to the structure as an O2 group, an OH group, as a hydroxyl group, and this process is known as hydration. So let's just look at them each on the. We're just going to look at ethene as an example, because it's the simplest example, so if we react ethene with hydrogen, so here's my C plus H2, I'm going to get, I break that bond, and I'm going to get an alkane, aren't I? It's just going to fill up with hydrogen. Lovely, okay? And that's relatively easy to do. Again, we'll just put this reaction down here. I've got my ethene again. This would be a gas at room temperature, but it's the quickest one to draw. We're going to add Br2 to, its example is bromination. Now this process here is called hydrogenation. Hydrogenation, it's often done with vegetable fats to turn them into solid fats, vegetable oils to turn them into solid fats. You hydrogenate it, it removes the double bonds and fills them in and turns them into something very similar to animal fats, saturated fats. So you'll see hydrogenation in food science a lot. Hydrogenation of vegetable oils to make them fats. Bromination is what we're going to do to test to see whether we've got an alkene. If this is an alkane and react it with bromine, nothing will happen. The bromine will still be there and we'll still have a colored solution. But if I react that, I'm going to end up with this structure here. And I'm going to have a hydrogen there, a bromine there, a bromine there, a hydrogen there, and a hydrogen there. So that's 1,2-dibromoethane. Okay, and then finally, if we're going to do a reaction with water, give ourselves a bit of room this time. And this is quite a common, the reaction is usually done with steam and rather than water, because you need the temperature, so it's steam rather than, it's carried out at high temperatures, but we're going to call it H2O as a gas, right? And that's going to form what we call an alcohol, and this is a whole new form of organic molecule. This is now, we're now moving into the realms of organic molecules that contain more than just carbon and hydrogen. And we're also moving into the realm of substituent branches and substituent groups that have functions, and what they're called is functional groups. So they're called functional groups because they're more reactive than the rest of the molecule. But let's have a look at what happens here. So I get my C, I've got an H here, an H here, and an H here. And then what I get is I get an OH here, and I get an H and an H. Okay, so what I've got here now is ethanol. And ethanol is methanol is going to be the first of our alcohols that we're going to look at, but ethanol is the second of the alcohols. The functional group is the hydroxyl group up here, and this process, this reaction, this addition reaction is a hydration addition reaction. So we've got brominate, so let's go back. You react it with hydrogen, it's hydrogenation, and you get an alkane. React an alkene with a halogen and you get a halogenated alkane, right? And then if you react it with water, you go from your ethene to ethanol, which is an alcohol with the functional OH group, the hydroxyl functional group attached to it. Okay, so there's a very quick rundown of the reactions. There's just one more reaction actually before we finish. If I take CH, if I take two of these things, I can break that off and I can get it to join to another one. So this is ethene, forgot the first E, plus and what does it react to form? Well, it reacts to form a polymer, because what I can do is I can have N of those and N of those, and they will react, so many of those, many of those, and they will react to form essentially a very long alkane eventually. Okay, so what we're doing here is we're and that goes on forever. So what we've got there essentially is a method of making alkanes from these, and this is known as addition polymerisation. Now, it's not very interesting to make alkanes using this, but if we do put in a brominated ethene of some kind, then we can make some very interesting polymers, but we'll come to polymers in another lesson. All right, I think that's enough for today. For this particular lesson, what we'll do is we will call a halt there, and hopefully that's less than 10 minutes.